This is problem number 2 from section 1.2. In this problem it says, for f of x equal 4 and g of x equal 3x squared plus 1, find the domains and ranges of f divided by g, and g divided by f. Let's start by, I'm gonna split this paper into 2 different sections. One section is going to be the work, and the other section is going to be our actual domain and ranges. So I'm just going to name those domain here, range here, and we'll write f of x, g of x, right, because they want f and g. Then they want f over g, so f divided by g of x. And then they want g divided by f of x. All right, so we've got everything written out what we need to find. So now we need to start doing some work for this. So for f of x, what's the domain for the f of x function? Well, f of x equals 4. So this is pretty simple. You can plug anything into this function because the output every single time is 4. So the domain of this function is going to be negative infinity to infinity, because no matter what you plug in, you get an output of 4. All right, so you can plug anything in. And the range then is going to be just 4, because the only thing that you get for an output is 4. So that f of x function is pretty easy to work with. F of x equals 4. Now g of x, its domain, this is a polynomial or a quadratic, however you want to categorize it. Either way, because it's got the x squared, its domain is negative infinity to infinity, because we know all polynomials or quadratics have that domain. Its range, though, is going to be slightly different. So if I plug in into 3x squared, I'm just going to plug in a couple things. So let's just say I do g of negative 1, g of 0, g of 1. So g of negative 1 will give you 3 negative 1 squared plus 1, which is going to give you 1, so you end up with 3 plus 1, which is 4. If I do g of 1, I get the same thing, because I get 3 1 squared plus 1, which is 4. But if I do g of 0, I get, when I plug in 0, I end up with 3 0 squared plus 1, which is 1. So actually this part, this g of 0, so this x value of 0 is actually what we call the vertex. Right? So this is actually the 0, 1 is the vertex for this function here. So the vertex is going to be your smallest range value. So our smallest range value is actually 1, right? Because that's the output value. So we're going to have this from 1 to infinity as our range. And it was pretty easy to come up with that. You know you have a quadratic, so you know that you can find that the quadratic has a vertex, which is either highest or lowest point. Now they want you to do f divided by g of x. So to do f over g of x, we're going to write this as f over g of x is just going to be 4 over 3x squared plus 1. So what can we have for a domain? Well, our domain is going to be the exact same thing, right? Because we're still just plugging in whatever. We can plug in any number in here. As long as, now you do have to watch out, you cannot have the denominator equal to 0. But that's not going to occur here, because we have an x squared in the bottom, which is going to make any number we plug in here positive. And all of those numbers are going to give you something that is larger than negative 1. Because negative 1 plus 1 is the only way to get 0 here. So we don't have to worry about that case here. So we can just say our domain for this function is negative infinity to infinity. And you could test this. I've done this before where you take the denominator and you say 3x squared plus 1 cannot equal 0, and you solve this. So 3x squared cannot equal negative 1 when you subtract it over. Divide by 3, you get x squared cannot equal negative 1/3. Now you notice I'm going to do the root. Well, I can't do the root of a negative, so this is not a possible situation. So that's how we know that that domain is negative infinity to infinity. Now the range value is a little bit different. So the range value is going to, we're going to have to do a little work on this. First of all, we know that the our range value for our g of x function goes from 1 to infinity. And we can actually probably just look at these two range values to come up with this. So I have 4 over the range values listed here. So if I do 4 over 1, I get 4. 4 over 2, which would be the next one, would be, or next integer would be 2. 4 over 3 is now like 1.3. 4 over 4 is 1. 4 over 5 now is less than 1. And I get 4 over, like, let's do 100. Now it's like 0.04. 4 over 1,000,000, I'm getting really close to 0. Do I ever touch 0? No. I'm never going to touch 0. So my range values vary from 4 over 1, which is 4, all the way to 0, but not including 0. So I have 0 here to 4 for our range values. Now g over f of x. I'm going to do g over f of x. So in this case, I do 3x squared plus 1 all over 4. Now we're going to do the domain here. Again, I can plug anything I want into this, so our domain still remains negative infinity to infinity. But our range value, what's our range value now? Well, now I'm taking this domain value, or sorry, this range value for g of x, and I'm dividing it by 4. So I can see that 1 divided by 4 is an option. And so just keep in mind, I'm doing the g of x function over the f of x function. So 1 over 4, and then I could do, I'm just doing integers. And then the next one would be 2 for the, between 1 and infinity, right? So essentially what I'm doing is I'm doing this. This range value divided by 4. That's what I'm testing here. So that's 1 over 4, 2 over 4, 3 over 4, 4 over 4, 5 over 4, 6 over 4, 7 over 4, right? You get the idea. This is getting larger and larger, right? Yeah, we're going to approach infinity over here. On this side, the smallest value that we got is 1/4. So our range value goes from 1/4 to infinity. And that's how we come up with the domain and ranges for these two functions.